So welcome back to the course, and in this lesson we're going to be talking about the connection between vegetation, or what we call the biosphere, and the climate. On this map we can see that on a fairly coarse division we can describe the different types of vegetation in different parts of the world here by simply looking at maybe the 7 different categories. The color on the map is shown also by the color of the circle around the text. So if we look at the furthest north around northern Canada, even parts of Greenland, the northern parts of Asia, we have the tundra in the purple. Then we have the coniferous forests, the boreal forests, which we can see below that. The yellow regions are the grasslands. The orange areas are the desert regions with the desert vegetation. And as we come to the tropics, we have more shrublands, and eventually the dark green, the rainforests, which we have, say, in the Amazon, in the Congo, and parts of Southeast Asia. So this is a very coarse division of type of vegetation, which we see is linked somehow to the climate because we have much warmer and wetter climates in the rainforest compared with much colder and drier as we go to the north. But vegetation is not just on the land, we also see it in the ocean. And here we can see an animation of both the land vegetation shown by the green shading over the continents, but also in the oceans, the greens and blues, where the scale on the land is given by a satellite index we call the NDVI, which has been converted to for where we see the green areas over the land. We have more vegetation. Where it's brown, we have less vegetation. You can also see the seasonal cycle between summer and winter, where in the winter we have a lot less vegetation in North America and Asia. In the summer months we see the greening of the higher latitudes. And the ocean data is giving the chlorophyll concentration, also measured from satellites. The greener areas, you can see the color bar at the bottom, the green, yellow, and the reds are where we have lots of biological activity in the ocean, basically what we call phytoplankton, microscopic algae and plants in the ocean, which is the beginning of the food chain, which is the food for microscopic fish and animals. And so there's a lot of biological activity, plant activity also happening in the oceans, which also varies by seasons, but it's also influenced a lot by the ocean currents. So again, very dynamic changes in the vegetation in the oceans and the land continuously throughout the year. And you can see that in this animation. So the first person who really linked the climate with vegetation was Holdridge. And Holdridge in 1947 built this categorization of vegetation, which he used 2 parameters, temperature and precipitation. And he said that we can take these 2 parameters, and just by knowing how much rainfall falls in a location and what the temperatures are, the ranges of the temperature, we can actually estimate the type of vegetation we'll see in any region. And he developed this triangle or pyramid, which has these hexagons, which shows different types of vegetation. And we can see here, basically, we have the annual precipitation in a certain location in millimeters. These are the lines, the diagonal lines, which go from the top, the 62.5 annual millimeters per year, which is very dry, and going all the way to the bottom of 16,000, which is millimeters, which is very moist, like the rainforests. On the other side, we have what's called the potential evapotranspiration. This is related to how much evaporation we have from the vegetation, is related mainly to temperature. And the vertical lines, the horizontal vertical lines, represent also what we call temperature or biotemperature. And this could be either changing the latitude, so going from the tropics to the poles, or going up a mountain from, say, sea level up to the alpine regions where we also have cold temperatures. And so we can see that if we take, say, a very hot and very dry region, which will be a desert, for example, like the Sahara Desert, this will be very hot and very dry. But we can also have deserts in the polar regions, which are much colder or much higher up in altitude, but also have very little rainfall, like we spoke about before in the cryosphere, say Antarctica, which is very cold, but not much precipitation. And then when we go to in the other extreme, where we have very warm temperatures and lots of rain, this is where we have the rainforests, another extreme. But and we can play around with this pyramid and look for any combination of rainfall and temperature and try to define the vegetation we have in that region. And Holdridge built a map that we can see here, where the different colors are similar to what we saw in the first map, where here the different colors are defined by the different types of vegetation which were calculated based on temperature and rainfall based on this Holdridge life zone schemes. And it actually does a fairly good job at actually describing the major types of vegetation as we go from, say, the rainforests to the boreal forests in the northern latitudes, to tundra, to deserts, to grasslands, etc. Now, vegetation is really important when we're talking about climate and climate change, because the vegetation is actually the interface between the surface of the earth, where we're storing both greenhouse gases in the carbon in the soils, in the roots of plants, but also water, which is in the surface, and what's happening in the atmosphere above it, where we live. And so there's a lot of interaction between the atmosphere and the surface, and the vegetation is kind of the middleman. It's helping with the transfer of many processes. And when we talk about heat, for example, the interaction between the sunlight and the surface, vegetation is important. How much of the vegetation will shade the surface, how much will intercept the sunlight, and the radiation, the trapping in even of infrared radiation emitted by the surface will be trapped partially by the leaves of the trees, which can have an impact on the radiation balance. When we talk about momentum or the winds, when winds are blowing in the atmosphere, if we have very high trees and forests, this interferes with the flow of the wind compared with very low grasslands. And so the interaction of the winds and the wind speeds at the surface are also linked to the type of vegetation, the thickness of the height of the vegetation. Obviously, all the moisture balance, how much of the water is stored in the surface, how much gets released back into the atmosphere, goes often through the vegetation, through the roots of the plants, through the leaves of the plants. And normally when we have also more vegetation and more roots in the ground, the soil can also be held together in times of heavy rainfall and prevents massive erosion. Trace gases, obviously plants through photosynthesis take up carbon dioxide. They also release water vapor and oxygen, and therefore plants are extremely important when we're talking about the carbon cycle and how much carbon dioxide is taken up by plants or released by plants. And even aerosols, the tiny particles that we cannot see, but they can be in the air around us and can impact both our health, the amount of particles, but also they can impact clouds through the production of cloud droplets, can affect the albedo of clouds. And so plants are extremely important. Vegetation, the biosphere, is extremely important in how it interacts with the atmosphere, the exchange of heat, of moisture, of momentum from the surface to the atmosphere, and also further on through impacting clouds and the hydrological cycle.